Hello everyone, myself Paul Gari Venkateshwarlu, PhD Research Scholar. Geotechnical Engineering is my specialization. Department of Civil Engineering, IIT Delhi. In this video, we are going to study the effect of angle of internal friction and cohesion on factor of safety of soil slopes. Here we are going to consider a simple soil slope using GeoStudio 2021.3 version using slope W module. This is the simple slope, 20 meter of height and 60 meter width, and the slope angle 33 degrees. Here I am considering very simple slope and without any water table effect. Unit weight of the soil is 25 kilonewton per meter cube, cohesion 10 kPa, angle of internal friction 30 degrees. And input parameter is considered, geometry is a 2D geometry we are considering, not for 3D. Element thickness 1 meter, slip surface left to right. This again depends upon the geometry of the slope. Slip surface option entry and exit. Another method is also available, that is grid and radius. Here I am considering only entry and exit method. Minimum slip surface depth 0.1. Number of slices 30. This again depends on the size of your problem. Maximum number of iterations 100 I kept as default. Tolerable difference in factor of safety is 0.001. Number of critical slip surfaces to store 1. Tension crack option no tension crack. Distribution constant. And here I have saved video of the simulation simple slope. Now giving the title of the project. Next initial setting all are constant. Now adding the 2D geometry and adding the slope W analysis using limit equilibrium analysis. Next adding the analysis. Now selecting the Bishop method. Here I am not selecting any type of water table. Now slip surface entry and exit. This is the left to right, entry and exit were selected. These are the parameters I kept as a standard, and these parameters are constant for all the further simulations. The geometry of the slope is simple. You can draw directly. If the geometry is complex, then you can draw in AutoCAD. Then you can import that AutoCAD drawing into the GeoStudio. Then you can perform for that complex geometry. Now I am selecting defining the material. This is the defining the material, giving the title to the material, then selecting the more column analysis, and here is unit weight 25, cohesion 10 and phi 30. Next assigning the material. Now the material is assigned. Now I am going to give the entry and exit points. These are the points, selecting entry and exit points. Now the problem is saved. Now run the simulation and the slip surface is presented. Here is the factor of safety values, and you can see the forces on each slice by clicking the thing. Now you can export the report also. So in this report also you can see all the information what you are defined. So now we have seen the video of how the simulation was performed, and the same video I have given in the second video. You can see the slow version of the video. This is just because of this is just how the simulation was performed, to just give the overview. And here is the here are the result. Bishop method, if you do angle of internal friction 30 degrees, then the factor of safety is 1.501, and if it is the angle of internal friction 31 degrees, then the factor of safety is 1.544. So the difference in factor of safety is 2.86%. So, and if it is the difference in angle of internal friction is 2 degrees, then the difference in factor of safety is 5.66%. Difference is 3 degrees, and difference in FOS is 8.52%. Difference is 4 degrees, difference in FOS is 11.45%. Difference is 5 degrees, and difference in factor of safety is 14.45%. The summary says that with the increase in the angle of internal friction, the factor of safety will increase. First point. And the second point, if we make an error of consideration of 1 degree of angle of internal friction, will lead to 2.86% of error in factor of safety. And by mistake, if we consider plus or minus 5 degree of angle of internal friction, that leads to an approximate error of 11.45 percentage in factor of safety. So it is very important to measure and to take the angle of internal friction value in the numerical analysis problems very accurately. And coming to effect of cohesion, and the same Bishop method, and initial parameters are all constant, and cohesion 10 kPa and 10 kPa to 11 kPa, and the difference is 2.79 percentage. And if the difference is 2 kPa, difference in factor of safety is 5.52 percentage. Difference is 3 kPa and difference in factor of safety is 8.06 percentage. Difference is 4 kPa, difference in factor of safety is 10.19 percentage. And difference is 5 kPa and difference in factor of safety is 12.25 percentage. Difference is 10 kPa, then difference in factor of safety is 22.65 percentage. In summary, it is clear that if the cohesion increases in kPa and the factor of safety also increases, this is the first point. And the second point is, if we make a mistake of 1 kPa negligence in the consideration of numerical analysis, will lead to 2.79 percentage of error in factor of safety. So it is very important to consider accurate value of cohesion in the numerical analysis, so that it directly implies that it is very important to consider a proper value in the laboratory also while calculating the angle of internal friction and cohesion values. Thank you for your attention. Thank you all.